Hey guys, alright, so today we're going to go ahead and start with our very next lesson. We have already finished Module 6, you guys just finished taking your test for that, and we're going to go ahead and jump into Module 7. For Lesson 7.1, we're going to be talking about arithmetic sequences, which is probably going to be a good thing for a lot of you guys because it's kind of going back into, I think it was Module 5, so it's going to be a little bit of a repeat from what we've done before. We're just going to be building on that a little bit. So we'll be talking about recursive rule and explicit rule. Okay, so let's get right into that. Alright, so first things first, let's talk about our essential question. Okay, so our essential question for this lesson is, how are rules for arithmetic sequences and linear functions alike, and how are they different? Okay, so that is what we're going to be dealing with in this lesson. Okay, so first things first, let's do this explore activity. All you're really doing in this one, as you can see, this looks like something, or at least it should look familiar to you guys. You have a function table where they give you a rule. Okay, so here it says that avocados cost $1.50 each at the local market, and the total cost in dollars of A avocados can be found using C of A equals 1.5A. So C of A, the cost of avocados, equals 1.5 times the number of avocados that you buy. So 1.5 has to do with the amount that you're spending. So $1.50 per avocado. Okay, so the first thing we want to do is go ahead and complete our table here. So if we substitute 0, so this is going to be our x value, and this is our y value. If we substitute 0 into our equation, you have 1.5 times 0, okay? And so I'll go ahead and write it like this just in case if that kind of helps some of you guys out, okay? And so 1.5 times 0 is just 0. 1.5 times 1 is 1.5. 1.5 times 2 is 3. And then 1.5 times 3 gives us 4.5. Okay, so now it's asking us here to list the consecutive elements of the range. Okay, so it's asking us for the range, and consecutive means one after the other. So we have 0, 1.5, 3, and 4.5. Okay, now over here it's asking you what is the difference between any two consecutive elements of the range. Okay, and what we're going to be doing is basically finding how that what the rate of change was. And so from 0 to 1.5 it increased by 1.5. From 1.5 to 3 it went up by 1.5, and the same over here. So our our difference is 1.5. Okay, and we're going to say that this was increasing each time. Okay, now that is kind of a little bit of a foundation of what we're going to be working with in this lesson. Okay, so now we're going to be writing rules for arithmetic sequences. Now this sounds like it's going to be a little bit more confusing than what it is because arithmetic sequence, but honestly we've already done this, and if I'm not mistaken it was Module 5 when we talked about recursive rule and an explicit rule. Okay, so here it says that an arithmetic sequence is the difference between consecutive terms. In an arithmetic sequence, the difference between consecutive terms is always the same. Okay, so your difference is always going to be the same. What that means is that you're talking about having a constant rate of change, or a slope, basically a constant slope. And here it says that the constant difference is called the common difference. Okay, and it's often written as D. Okay, so you'll need to remember what that variable means, because when we're looking at the formula for how to create an explicit rule, the variable D is what is going to tell you what the common difference is. Okay, so here it says to write rules for an arithmetic sequence, you first want to find the common difference. Okay, so we're going to go into this first example down here, and so it says this table shows the end of the month balances in a bank account that does not earn interest. And it says it's asking us to write a recursive rule and an explicit rule for the arithmetic sequence described by the table. So the very first thing we want to go ahead and do is, remember when we were talking about recursive rule, you always need to write your very first term. So you know right here that when n is 1, your f of n, which remember is the same as y, this is going to be 60. So you have to write that as part of your rule. That's very important, okay? Now here we want to see what our difference is. How is this increasing every time? So from 60 to 80, we went up by 20. From 80 to 100, again, from here, and then also over here from 120 to 140. So you'll see that every single time we're adding an amount of $20, basically, because we're dealing with money. Okay, now, I don't know if you guys remember, but remember back when we were talking about sequences, we said for a recursive rule, your formula always starts off like this, and then over here it was a plus or minus whatever the change was. Okay, so in this case, this is D, your common difference. Okay, now your textbook has it written kind of flipped. You see how they have this at the end? It's the exact same thing. So notice that this 20 is that common difference that we had before. Okay, so this is increasing by 20, so this is your common difference. Okay, and then this is always going to be n minus 1 because it's going to be the function of n minus 1. Okay, and then over here it's telling you the rule for when n is greater than or equal to 2. Okay, because you already know your f of 1, so it's whenever your n is starting at 2 or greater. Okay, so now let's get into our explicit rule. Okay, if you flip over, and this is on page 214, okay, here you see that they have a rule up here on how to find your explicit rule. So it says here to remember that D is a difference between the two consecutive terms. So this is the change. So that's why there's a 20 here, because that's how that was changing, okay? Now, it's 20 times 0, because remember, here you are subtracting 1 every single time. So your n was 1, so now here you're going to do 0. When it's 2, you're going to subtract 1 and you get 1. Okay? And so that's how you get these terms here. Okay? This is just, these numbers is what you want it to equal to, because we know that that's what it was. So our rule is going to be 60 plus 20 parentheses n minus 1. Okay? Because, like I said, the n minus 1, you're always subtracting from the previous n. Okay, so let's go ahead and let's see if we can do this your turn question together. So it says, the table shows the number of members in a theater group after n weeks. Write a recursive rule and an explicit rule for the arithmetic sequence. Okay, so first of all, let's go ahead and let's see how this is changing. Okay, so from 35 to 47, we see that we are increasing by 12. Okay, and if you go ahead and see all the other ones, you'll see that each one is also increasing by 12. We also want to point out our first term. So for our recursive rule, we have f of 1 equals 35, because we know that our first term is 35. Okay, and like I said before, whenever you're writing a recursive rule, you need to know what the first term is. Okay? And then because we're increasing by 12 each time, our rule, we're going to start off with f of n equals f of n minus 1, because that's how they all start off. And because this is increasing by 12, we're just going to do a plus 12. Okay? Now for our explicit rule, and I'll just write an E here, we're going to start with the 35. Okay? So we're going to start with f of n equals 35, because we want to start off with that first term, and then we're going to do plus our common difference and then times n minus 1. Okay, so it's your f of 1, whatever that f of 1 is, plus the common difference times your x value. But the x value is the n minus 1, because you already know what the first term is. That's why you need to subtract 1. So I know that it sounds a little bit tricky, but let's kind of roll with it here. With more practice, you'll see that it starts to make more sense. So right here, your textbook gives you general rules to use. So remember, you need to give your f of 1 first, and then you'll need to go ahead and do f of n minus 1. So this part is never going to change. And then here, this plus d, this, remember, is your common difference. Okay, so I'm going to call it CD, common difference. All right, and then over here, it's going to be basically exactly the same thing. The only difference is here, you're writing this separate. See how here we wrote f of 1 equals 35, but here we put the 35 in as part of the rule. So you're going to do that, and then plus the common difference times n minus 1. Again, this n minus 1 is not going to change. Okay, so let's go ahead and do some more. So now it says here to write a recursive rule and an explicit rule for the sequence 6, 9, 12, 15, and 18. So we want to go ahead and see how it's changing. So from 6 to 9, we increase by 3, and again, increasing by 3. Okay, we know that our first term is 6. Okay, so we know f of 1 equals 6 because our first term is 6. We saw that we were increasing by 3, so I'm going to substitute plus 3 for my common difference here, and so I just have f of n equals f times n minus 1 plus 3. Nothing's going to change there. Okay, so basically the only two things that you ever need to change, if you can remember this general format, the only two numbers that are changing is what f of 1 is equal to and your common difference. Okay, because here this is going to stay the same as well. Okay, so let's flip over. Actually, did we go ahead? We didn't write an explicit rule. So let's go ahead and write an explicit rule. Okay, so writing the explicit rule, again, using this general formula, we knew that our common difference was 6. Sorry, we knew that our first term was 6 and our common difference was 3. So those are the only two numbers that we need to substitute there. So this is your general formula. Then you're just going to substitute those numbers in there. Okay? So this is very important to remember, and always start by writing your formula first. Okay? So write it down. Write formula first. That's what you need to do. Okay? You always want to start by writing your formula first. So let's go ahead and let's practice with this your turn question. So it says to write a recursive rule and an explicit rule for the arithmetic sequence 20, 25, 30, and 35. I want you guys, and I'm hoping you guys will pause this video now. Go ahead and pause it and try to do this on your own. Give yourself a couple minutes. Try to see if you can figure it out. Okay? Then go ahead and push play again, and then I want you guys to go ahead and see if you got the same answer. Okay? So push pause. Alright. So, how is this changing? This is increasing by 5 each time. My first term, so I'm going to start with my recursive rule. My f of 1 is 20 because that is my very first term right there. So my first term is 20. I'm increasing by 5, so I'm going to start with f of n equals f of n minus 1 because again, that part doesn't change. I'm increasing by 5, so I'm going to write plus 5. Now for my explicit rule, again, my first term is 20, so I'm going to start with f of n equals 20, because that's my first term. And then I'm going to put plus 5, because that's my common difference, times n minus 1. Okay, so that's my explicit rule. Now relating arithmetic sequences and linear functions. Alright, so the explicit rule for an arithmetic sequence can be expressed as a linear function. You can use the graph of a linear function to help you write the explicit rule. Okay, so this is basically doing the exact same thing, only instead of them giving us a table, you're looking at it from a graph. Okay, so right here it says that the graph shows how the cost of a whitewater rafting trip depends on the number of passengers, and it's asking us to write an explicit rule for the sequence of costs. So right here it's asking us for explicit rule. Okay, so first things first, we're going to look at our graph. We know that 1, 2, 3, and 4 is our x value. 75, 100, 125, and 50 are our y values. So how is that changing? Okay, we see that from 75 to 100, it's increasing by 25, and each time, again, it's increasing by 25. Okay, so we found our common difference. Now we want to write our explicit rule. We know that our first term is 75. Our common difference was 25, so it's just a matter of substituting that into our explicit rule formula. Okay, so that's basically it. Okay, so I want you guys to try to do this one on your own. Okay, so here this is 0.120. Then this one over here is about 35 maybe. So we have 235. And then from 4, this one over here at 3 is at 50. So that's how you're going to be doing it. Go ahead and write down your ordered pairs if that makes it easier for you, and find out your common difference. Alright, so then I want us to go ahead and I'm going to do question number 1 with you, and then you guys are going to do the other ones on your own. Okay, so it says to write a recursive rule and an explicit rule for the sequence. Alright, so first things first, what goes in here? This is our recursive rule, and this is our explicit rule. Okay, we know that this is always going to be n minus 1, and then this here is going to be our common difference. So how is this changing? This is increasing by 1, so we're going to do 1 here because it's plus 1. Now over here, we know that our first term is 6, so I'm going to substitute a 6 here, and then I'm going to do n minus 1. Okay, and so that is our rule, our explicit and our recursive rule. Okay, so you guys have 3 questions to do, number 2, 3, and 4. And that's basically it. I hope you guys have a great time understanding this, hopefully, and let us know, your teachers, if you have any questions on any of this. Have a great day. Bye.